Hello everyone, welcome to Sky Observers Hangout. My name is Michelle and I'm the Director of Public Observing here at the Adler Planetarium. And I have a friend sitting next to me here today.
Yes, hello everybody, my name is Hunter. I'm Public Observing Educator here at the Adler Planetarium. Joining you here at Sky Observers Hangout at a little bit of a different time of day than usual, but for some very exciting astronomical views.
Exactly. So, Sky Observers Hangout, if this is your first time joining us, is a place for us to gather together to nerd out about the sky. Our goal is to give you practical tips to be able to find something useful, we hope, about lots of things related to sky observing. And if you have any questions today, or you just want to share your love of astronomy and all things observing, let us know in the chat. So if you're in the YouTube chat, you can send us questions and we will see them. And we hopefully will answer your questions during the show. To start off, I'd like to know where you're joining us from. So let us know if you're joining us from near or far. We would love to know that. While you do that, hey, the Adler Planetarium, hey, we're open for visits. This is during the day. We're actually open right now.
That's true. Museum's just open right about 200 feet away from us.
Exactly. So we've got some friends also helping us from behind the scenes today. You want to tell?
Yes, absolutely. So Jen will be in the chat today. You'll see that she will be there as the Adler Planetarium account. If you see that account posting anything, they will be able to help you with any questions, give you some useful links that will, apply to some of the things we're talking about today, and also be passing questions over to us. So any questions that you have, she will be helping get those to us. We'll also have, I think, our astronomer friend Geza will be joining us in the chat today. And so if you have any particularly challenging astronomy questions, he's the guy to go to for sure.
Something that can be answered in a chat form.
Right, exactly.
Jen is also going to put a link for purchasing tickets if you want to visit us here at the Adler sometime. That would be fantastic. We would love to see you. So folks can also help us out a little bit in our YouTube channel. You want to tell them about that?
Yeah, if you're joining us today here, you must have at least some level of interest in checking out our online content. At least a little bit. And so make sure to subscribe to the YouTube channel. Button's right down below. Check out other live streams that we have coming up, but also tons of other content that people from all throughout the planetarium are creating. So lots of really good stuff there.
And give us a thumbs up because that helps other people find our channel. So
exactly.
Today, if you've joined us before from Sky Observers Hangout, not only are we joining you at a different time, because we're usually on at night, it's daytime right here, and you might not recognize the background.
Yeah, kind of a weird background. Unless you've come and visited us at the Doan Observatory, this might be a new space for you. So usually, we're actually right inside that door right there. That's where the big telescope is.
Yeah, not this door.
Not that door. That door up there, the bigger one up there. But so today we're out on the terrace so that we can have a more direct view of the sun. We've got a little bit of a different kind of telescope helping us get some good solar views today. So.
Exactly. So you may see me also disappear off the camera view from time to time. That's because our telescope is right here, and the cord is only about that long. And so I need to disappear over there, recenter the view just a little bit. We've got a telescope that's tracking the sun. It's not quite perfectly tracking. It's okay. I just need to adjust it every now and then. But I was
going to say, we're talking a lot about the view in this telescope. So, yeah. I think we should probably skip over to taking a look at it for sure.
Let me adjust the view just slightly here.
Well, while Michelle's adjusting the telescope view there a little bit for us, before I get it on the screen for you, I wanted to point out a few places folks were joining us from. We've got lots of interesting locations coming today. We've got some more close by, Joliet, here in the city as well, in Chicago. A little further away in the States from South Carolina, also joining from Germany and India today.
Hey,
so
welcome.
Very exciting. If you're here close to Chicago, or probably pretty much anywhere in the United States, I'm glad that you get to stay inside and do some solar observing today because it is pretty roasty out here today.
Yeah, just a bit. We're under a pop-up tent right here, and we've got our table set up. We're in the shade, thankfully.
We're in the shade, yes, absolutely. But the sun that we're getting beautiful views of is definitely beating down. But that's exactly what we're looking for today, right? No complaining there.
No, this is live. This is a live view of the sun. Not the sun 10 minutes ago, not the sun half an hour ago or yesterday. This is live coming through my computer. So we've got a special telescope that we'll describe in just a little bit. But this telescope It has a camera on it. The camera is plugged into my computer, and the software that you see, the background that you see, is the software for the camera. So rather than like cut out all that stuff, I love to show you all the behind the scenes kind of stuff. So you can see exactly what I'm seeing on my screen. So the stuff over on the left-hand side is how we can adjust the exposure time for the camera, or and bump up the brightness electronically a little bit, which we don't have to really do.
Right, I was going to say, you can imagine that like a lot of the times a camera like this would be used for very different kinds of astronomy observing, right?
Exactly.
There's only one object as bright as the sun, right?
Yes.
Lots of objects that are much dimmer. So having those kinds of setting controls are really important. You know, our last show was looking at galaxies, right? Doing lots of very long exposures. I mean, upwards of, 30 seconds even during the show. What did we say the one is for today? Exposure time, 18 milliseconds.
Milliseconds, 18 1,000ths of a second. I think you can see my cursor right over here. So yeah, over here on the left-hand side, exposure time, 18 1,000ths of a second for the exposure time.
Very different requirements for looking at the sun,
yeah,
for sure.
For sure. But, oh my goodness, we get a cool view. By the way, I'm going to prove that this is live. Hang on. Hang on. I'm going to slightly adjust the position. Not because I have to, but I want to show you that really this is live. Otherwise, we've timed it just right, so I'm going to move it up a little bit. I'm going to move it over to the left slightly. There we go.
So let's talk a little bit maybe about we're seeing some movement here on the mount. Let's talk a little bit about the equipment that we are using today.
Yep.
So we do have a tracking mount, a tracking equatorial mount, right?
Yep.
So it is moving with the sky, with the sun, which is very nice. Makes it a lot easier. But it does require being very precise to track perfectly. So we'll have to check it every once in a while. But really, the mount is not the star of the show today. I would have to say that this fantastic solar viewing scope is really the star.
Yeah.
So what telescope do we have out here today?
Yeah, so this telescope we bought about 15 years ago. It was originally made, the company that originally made it was called Coronado. Now the company that makes these telescopes is called Meade, M-E-A-D-E. But this telescope is very, very special because it looks at one thing in the sky, and that's the sun. And not only that, it looks at one particular wavelength of light from the sun, specifically kind of a reddish, pinkish wavelength of light from the sun given off by glowing hydrogen. And so you are looking at the one wavelength of light that can get into this telescope. It blocks out all the rest. And it also cuts down the amount so that it's a safe amount for this telescope to look at. Because if you probably know, you shouldn't point a telescope just at the sun without some sort of special actual.
Really, really bright. So they have to filter out a lot of light.
Exactly.
Different kinds of solar observing telescopes might offer different views of the sun depending on how they are filtering down that light.
Yep.
This one in particular, like you said, is targeting this very specific wavelength,
Exactly.
Which is what makes these telescopes a little bit more specialized and really just used for solar observing.
Just to add in, the reason I have to adjust the mount that this telescope is sitting on is if the mount isn't pointed exactly north, then it is going to be a little bit off. And we're in a building, we're next to an awful lot of metal right here, and we're surrounded by a lot of concrete, rebar, all that kind of stuff. So all of that kind of messes with exactly where I can find where north is.
True, yeah.
So my phone is not going to be exactly right for finding north. So that's why I have to adjust it.
Folks that have used equatorial mounts before that may be joining us might be familiar with one way that a lot of people will test to make sure they are aligned north is using Polaris, using the North Star, right?
Yep.
Little bit harder to do that during the daytime.
Correct.
We can't see the North Star, so we have to do it a little bit less specifically accurate, right, with a compass.
Exactly.
But certainly plenty close, especially
Close
for
enough.
tracking something like the sun. We don't mind adjusting a little bit here and there.
Exactly. We get at least a few minutes worth. Otherwise, if we weren't tracking the sun at all, or how the sun appears to move in the sky, in reality, the Earth is turning. So if we didn't do that, it would slowly zip out of the field of view. Which,
Right, I think it only takes 2 minutes for the sun to move its entire diameter throughout the sky, so we'd lose it really quite
really
fast.
quick. Yeah. So anyway.
Well, I did want to touch on one other thing with the filter and the kind of telescope because I think it's really helpful in understanding what features exactly we are looking at today, what part of the sun we are seeing. So you mentioned that we are focusing in on this specific wavelength of light that hydrogen emits. It's this wavelength called the hydrogen alpha line, right?
Yes.
And so the narrower the bandpass, the more we are able to focus in on this light that is being emitted. Exactly. And why that's important is this actually isn't the layer of the sun that you would typically see if using a different kind of telescope with just like a more general white light filter on top, right? Yep. That would show you what we would normally call the surface, right?
The photosphere.
This photosphere is is what is the more accurate term.
Yep.
Surface, not quite right? Yeah. It's all gas, you
right,
know,
right.
But it's an effective term. That is where the bulk of the natural light that we are seeing is being emitted, right?
The word photo, so photosphere, made up of two words. The word photo means light. The word sphere means region. The region where we get the bright light that our eyes can see. Don't look at the sun. So that's the region that we're talking about for the as Hunter said, the bulk of the light that you can see. What we're looking at right here.
Now
is
this
not
one's
quite
interesting.
that.
Yeah. So I have a little graphic that I'm going to switch over to just momentarily. I know we'll keep it mostly on the live sun views. But this is going to showcase some of these different layers of the sun and help kind of explain what makes this telescope so unique. So the photosphere is actually underneath or closer to the core of the sun than the chromosphere is, right? You can imagine, using a term like surface that we used before for the photosphere, this is kind of like the atmosphere, right? You can imagine it like that. The closest Earth, representation would be the surface and the atmosphere. On the sun, obviously a little different, right? They don't have a rocky surface like we do here. But it is these different layers. This is kind of this upper atmosphere layer above the photosphere on the sun. And you can really see that demonstrated in the slideshow here. So only can you see this chromosphere when narrowing the light down to this specific wavelength. And why is that? What's special about the chromosphere that this hydrogen alpha line makes it easier to see that layer of the sun?
So when you have hydrogen of a certain temperature, it's going to give off primarily certain wavelengths of light, and this is that. So the chromosphere is, as Hunter said, a little higher in altitude away from the photosphere. If Geza is listening, if he could put in how far in altitude the chromosphere is from the photosphere, I believe it's in the range of a few hundred miles.
I was gonna say up to 1,000, maybe.
Something like that. So he can put exactly. The photosphere just swamps the chromosphere. The light is always coming at us. It's just swamped. And so the glowing hydrogen of a certain temperature is what we're looking at here. And also, when we adjust the exact amount of the wavelength that the telescope can see, we get to see even more. And I did that.
Right. So I was going to say, let's switch back over to this view. And, it's actually really interesting to see it changing live while you do it. So
why don't I do that?
You want to narrow down to this really specific wavelength, right? And when I say really specific, it's 656.28 nanometers of wavelength. It's really particular. And so all of these H-alpha telescopes, their filter is adjustable so that you can narrow in on that exact wavelength of light. And you can see the image changing a lot as Michelle adjusts it. See, you'll see that sometimes it looks like more just kind of flat, bright red. And when you get that bandpass focus just right on the wavelength, it reveals so many more details. And I would really love to talk about some of those details now. We've talked about the telescope and the layers, but I am seeing so much cool stuff, especially with this really nice H-alpha that we have. This one is a Solar Max 90 millimeter. And it just picks up so much stuff on the sun. So if there are any features that you see on the screen right now that you're wondering about, definitely ask about them in the chat. I know I'm seeing a lot that I'm wondering about right now. So there definitely will be no shortage of things to talk about. But if there's one that you particularly would like any questions answered about, feel free to post those in the chat.
I just can't stop looking at it. It
I
is
know, it's so cool. It
But,
really is awesome.
Yeah, why don't we take a little tour of...
I think a little tour of the sun would be
sun.
great. So what do you think we should start with? Should we start in the middle or on the edges?
Oh, gosh.
It's a hard
let's start
one.
with the edges.
I think the edges that's my personal fave feature.
So you can see the little cursor that I've got. I'm moving my cursor around on the screen. There are these little features that seem to stand away from the sun. And in astronomy, we love confusing you. We name things, but sometimes the names, once we learn what stuff is, we don't change the name to something more descriptive. So in this case, these things that seem to be a little bit away from the sun, we call them prominences. As in, this stuff, whatever it is, stands prominently away from the edge of the sun. So, does that tell you what it is? No, but it tells you what it looks like.
Well, I suppose back when they named them prominences,
yes,
they probably didn't really know what they were,
they
right?
Did not. They did not.
I think these were being discovered, couple hundred years ago.
1800s, yeah. So the mid 1800s to latter 1800s, I read an article from about 1890, 1895 that basically said, hey, astronomers, this word that you use to describe these things doesn't really tell us anything. Could you come up with something better? And no, we didn't. Of course, I wasn't around then.
It's either like the first descriptive word they can come up with,
yep,
or somebody's name.
Right.
Those are kind of the two options, right?
So what this is material, plasma, hot glowing gas that is looping up and away from the surface of the sun. And so these loops can be different sizes. The ones that we're seeing here, they're not especially huge, but that's okay. What is kind of deceiving is what huge really means. Like this one that's right next to where that little hand cursor is, you could probably fit the Earth underneath that.
I was
one.
wondering,
Probably
I don't think I have any pictures in here particularly comparing the Earth to the sun. To give you an idea of scale, you could fit 109 Earths across that image of the sun now. Yeah. I guess since this is the chromosphere, maybe 109 and a half or something. But so you can imagine 1% on that image is the size of the entire planet Earth.
Yep.
So a lot of prominences, these ones aren't particularly huge today, but they can easily erupt in the up to 100,000 miles off of the surface of the sun, easily. Right? And the Earth's only like 8,000 miles wide. So most of these are like so big that they could easily engulf the Earth, right? I mean, it's just incredible to think about that scale and give yourself some perspective of it.
So let's go to the twin of the prominence, which is this kind of curved line-looking thing. You can see a few of them on the image. Those are called filaments because that's kind of what it looks like. If you think of like a filament for a light bulb, if you've ever seen an incandescent light bulb innard, then it kind of looks like that. What we realized after these things were discovered and named was a filament and a prominence are the same thing. Material looping up and away from the surface of the sun, following the magnetic field of the sun. And we just never changed the name. But a prominence is a filament seen from the side. A filament is a prominence seen from kind of the top down.
Right. And actually one of these filaments here, I think you can really clearly tell that that's what it is, that big one there.
Yeah.
You can almost feel the three-dimensionality to it.
Exactly.
I sure wish that one was on the side because it looks massive, honestly.
Right? Yeah, exactly.
And if you're really lucky, you can sometimes see them kind of transitioning between those two kinds of layers, which is pretty cool.
I'm going to increase the zoom on this just a tiny bit.
So I was going to say, we might be able to narrow in on some of those prominences a little bit. And, we might even be able to check and see if the bottom right side of it has some, because the top left ones are more in focus on the filter right now.
So what I'm going to do is I will adjust the position slightly, and then there's a handle on the side of the telescope where I can adjust the wavelength of light coming in just a tiny bit.
Right, it actually changes how far apart the different filters are, right?
And that can affect sometimes the visibility of certain things. So I'm going to go over there and do that.
I mean, you can kind of see that line across where in the bottom right it's more red, and then in the middle top part it's much more yellow, and you can see much more details, some of that granularity on the surface.
So adjusting.
Even just that has helped us really reveal this one over on the right side there that you can see is definitely a lot bigger coming off of there.
Yeah, looks like they're not terribly big.
Not particularly huge stuff down in the bottom right corner, but still very, very obvious that we have things coming off of there. Exactly. Now, we've talked a lot about what they look like, this kind of history around them, seeing them. I feel like we haven't talked a lot about what exactly they are and what is causing them to happen. And there's really a common thread in a lot of the different features that we're going to be looking at today in their cause.
Yep, magnetic fields. So if you've ever done a little experiment, and if you haven't done this, it's fun to do. It takes like 3 seconds. You take a bar magnet, you put a piece of paper over it, you shake iron filings over the piece of paper. Why do you not just shake them on the magnet? Because you'll never get them off. So if you want to actually recover those iron filings and use them again for something else, great. So bar magnet, piece of paper, iron filings, you'll see this kind of butterfly pattern. And that is showing you 2 dimensions of the 3 dimensions of the magnetic field of that bar magnet. Well, what you're seeing in this image is lots and lots and lots of twisted up bar magnets, essentially. The sun's magnetic field is very complex. And so the prominences and the filaments are material that is coming off the sun and following. If you think of the bar magnet picture and those kind of loops on either side, imagine the prominence is half one of those loops, whereas the other side would be inside the sun. So you got one side reaching out and one side would be reaching in. But you can see the out part right there. And once you think of it that way, you go, oh, well, I can imagine that one end of the bar magnet is at this end of the filament and the other end of the bar magnet is at that end of the filament. And these prominences, same thing. You just can't see exactly the starting point and ending point. They're a little less visible there just because they're smaller and they're at the edge. That's all.
Right, like a lot of those could actually be kind of around on the back side of the sun that we're not able to see right now, and we're just seeing the little edge of them. You never know. We might be seeing the top of it or something. Yeah. But all these other little filaments, I'm saying little. These are these are really big ones,
really
honestly.
Big. Yeah,
really
actually,
big.
This one right here.
Pretty...
It's what, maybe 10% the diameter of the sun, maybe 15%. So the distance from one end of this filament to the other at about 10%, that's probably 100,000 miles.
Exactly, 10 to 15 Earths.
Yeah,
right.
Easy.
I mean, when you can start measuring things and how many Earths wide they are, that's when you know that you're big. Like really dealing with crazy stuff, big. Right?
Yep. So we've also got these brighter areas. Those are called plage, Plage. If you speak French, you may recognize that word. The word plage means beach. Is this a beach on the sun? No, very much no. But this area is where the magnetic fields are a little more twisted up, a little more active, which makes sense. You're going to find those twisted up areas and the prominences and the filaments and also the sunspots in the same general vicinities.
Right.
Now, folks may be asking, so where are the sunspots? I've seen sunspots in pictures. Why aren't you showing me sunspots?
Can we make any of them out? There's a couple of them you can kind of see in like that group of plages. Exactly. So they often are grouped with the plages, where the sunspots will be actually the areas that are like a little colder, and those wider plages are a little hotter, and it's all based on that same magnetic activity going on.
So the key point, though, is the sunspots you're generally going to see in images that are showing you the sun's photosphere. You're not going to see them as much in the chromosphere. So
we have some good example pictures of that later when we're talking about how folks can observe from home, because
exactly.
those are one of the easier features to catch. I figured we'd bring the extra cool ones like the filaments and prominences today.
Yep.
We did have a good question about the prominences in the chat. So the question is, do the prominences emerge explosively? What could be the velocity of the plasma?
Oh,
that's a really good question. And this is something that this kind of leads into another question that I find I get a lot when doing solar observing, is comparing these to solar flares. A lot of times people assume that that's what they are when they first see them, and kind of the speed that they grow at and how long they last is really a major distinction between the two. So I think that's a really interesting question to discuss.
So I don't know the speed off the top of my head, so maybe Geza can help us out with that. But I will describe what's kind of going on. So the magnetic fields get twisted up a bit, and you can sometimes have this material coming off the surface of the sun. Now these prominences and filaments, they could last for minutes or hours. And so maybe even longer. It depends on how magnetically active that part of the sun is and how long that activity lasts. They won't necessarily be explosive. they'll be rather gentle. You could actually, over the course of maybe a few hours, if we were to keep pointing the camera at that filament, you'll probably see some change
for sure. Yeah, I mean their lifespans are usually in the range of like hours to up to like a day, right? They're usually not lasting much longer than that,
right?
Unlike sunspots, which can hang around for a little longer,
for hours, days, weeks,
right? Even up
months.
To like a month almost sometimes. Yeah.
So when the magnetic fields, though maybe there's a prominence there, maybe not. If they get really twisted up and those magnetic fields suddenly break, that's when you can get this release of energy from the breaking of that magnetic field. That's a solar flare.
Right.
Then if that release happens and it's big enough and it lasts long enough, you may get a release of a vast amount of material being released from the sun. That's what's called a coronal mass ejection. So not every flare produces a coronal mass ejection. Not every prominence will produce a flare.
Right. But
that's generally the what's going on. And the sunspots are also telling you where you might get some of this activity as well. I'm going to move the telescope again.
Yeah, and one thing I do want to point out, I was like, all right, while the flares and the coronal mass ejections may be like, I guess like the most explosive events, right? These ones that are moving most quickly and are most sudden. These prominences are of course still moving incredibly fast, right? We're talking about the amount of time that they last in, upwards of 24 hours. And they are arcing across areas of space that can be hundreds of thousands of miles wide. So they're still moving very, very quickly, but maybe don't quite compare to some of the other solar features that you'll see. So really, really good question. Thank you for asking that. And, one thing that I love about doing this solar observing is the fact that so many of these features that we're looking at, things like the prominences, things like the sunspots, right? They do have a more limited time frame, right? And that means that every single day when you look, it's always something different, right? It's always interesting to look at. And that's what makes it so fun. You might be like, oh, who's getting telescopes out in the middle of the day, right? There's nothing to look at. Well, there's one really big, close thing to look at, and it's got a lot of cool stuff.
Who's getting telescopes out during the day? We are. So, when those coronal mass ejections happen, there is a velocity I can give you there. So when the flares happen, the energy is being released. That's at the speed of light, of course. So it's X-rays and all sorts of stuff. If it's a coronal mass ejection, you can get the material being released at 1,000,000 miles an hour.
Wow.
So the flare the energy will go out, and it might encounter Earth in 8 1/3 minutes. That's how long it takes light or energy to get from the sun to here, traveling at the speed of light. If it's a coronal mass ejection, that material, protons, electrons, that stuff is going more slowly, but still really fast. Really fast compared to our everyday existence.
Oh my gosh, yeah, it like doesn't really compare to stuff that you have on Earth, right? That's one thing you have to remember when looking at all this astronomy stuff, is the scales are completely different than what we're used to.
Exactly.
So a nice slow prominence is erupting at an incredibly fast speed.
Great question. I now see.
How big are sunspots? Another question that we have. Yeah, so we've talked about how big the prominences are. The sunspots are a little bit smaller. We would measure them more in like planetary sizes. So I would say typically in the range of kind of like Earth to Jupiter is about the range that you get. Now, sunspots, those will be the individual spots, and when we have the picture pulled up of them later, you'll get a better view of them. They can be clumped together.
Do you want to show them the sunspots?
Yeah, here, let me pull it up. Sorry, I gotta skip ahead to what I've got. So this shows the sun as seen through a white light filter. I did include this awesome picture of the bird in front of it as well. So these were taken by one of our wonderful telescope volunteers. Bill Chu, if you have looked through a telescope in Chicago, there's a good chance that it could have been with Bill.
Right.
And so this is the white light filter. These are ones that you can use with any kind of telescope as long as you put that filter up front, right? And so you can see that these are the kinds of spots that you would typically expect across the sun. This is from just within the last 2 weeks, maybe these were taken.
Yep.
So like this one would maybe be one that's like a little bigger than Earth,
maybe Uranus sized.
Right, maybe not quite Jupiter sized. And then like these little ones down here are a little closer to the size of the Earth usually.
Yep.
And this picture is just awesome. He happened to get one while a bird was passing in front with the sunspots on it.
The bird being much closer.
Yes. The bird, obviously not a feature of the sun, but it was just a great picture. I had to include it in there.
Exactly.
All kinds of surprises you can get.
I saw that one and I thought, oh, we're going to see that one in the show. So, yeah.
So that gives you a better idea of the sunspots. It's not a feature that you can make out super clearly in the hydrogen alpha, but that is because they're a little bit lower down in the sun. Closer to that photosphere is really where the sunspot activity is. So you don't see them super clearly on these. I would say that sometimes if like maybe you know where they already are right now, it can be easier to spot them out. But the Plages are a pretty good indication that you have one around that area at least.
Yep.
Often kind of in the center of them.
If your sunspot is particularly magnetically active, you'll kind of see that. You'll sometimes see sunspots in this chromosphere, in this view that we're getting from our special telescope right here.
Yeah,
but thank you for that question.
Yeah, that's a really good one, and that's a feature that we were focusing on a little less today. So It's nice to get that brought up. Now, one other kind of like smaller thing that I noticed when I look at this is when we looked through when we saw the white light filter images, the sun was kind of a uniform color, but on this one, there's like much more texture to it, almost like dimpling. Can you tell us a little bit about that stuff? I mean, it feels a little separate from the rest of the features.
Yeah, so that feature there, that's real. But the one thing I do want to mention, I'm actually glad you mentioned the colors are a little different. When I adjust the wavelength of the telescope, you'll see the color kind of changing across the view of the sun. Because the sun is a rather extended object to this telescope, I can't quite get the whole thing to line up exactly with just the filter itself.
Right.
It's gonna, when I do that, I'll do it in a second, but when I do that, you'll see that kind of filter, you can see it kind of washing across the image of the sun. But,
right, that's why some of it has that more red color on there. Really,
yeah.
The true image that we're looking for is that more textured part of the top.
Exactly. And so when you see close-up images, especially of the photosphere, you'll see what's called granulation. And granulation is bubbles of material coming up from the sun's interior like a lava lamp. Think of a lava lamp. The incandescent light bulb warms up the blobby material inside the lava lamp. It heats up, it rises, it sits there for a second, cools off, and falls back down. Imagine the sun is made up of billions of little lava lamps. But these lava lamp bubbles are about the size of the state of Texas. And so when you see a close-up image of the sun, you might see the tops of these bubbles. And so, but in the chromosphere, it's kind of it sort of looks like a similar feature.
Right, yeah. I mean, I can even make it out. It's pretty bright out here, so it's honestly kind of hard to see our screens right now. But I could even make out some of that texture, and I think seeing that granularity all along there, I don't know how to say this without sounding a little silly. It makes it look hot to me, right? Like it looks hot and active because of that. And here you can really see a lot of that detail. I love being able to see some of that stuff along the bottom side there. Wow, look at those plages down there. You can just really feel how lively the sun is, right? And how active it is. Fortunately, it's only about halfway through its life. It's still kicking strong. Been around for 4.5 billion years now.
5 billion. Got another 5 to go.
Yeah, exactly. Still got lots more to go. So.
By the way, just to reiterate, for folks who are just joining us, going, wow, that's a cool image of the sun. When did you take that? It's live. This is a live image of the sun from our telescope that we've got here sitting next to us. We weren't sure if we were going to be able to show you an actual live view of this whole setup because our camera cord is a little short.
It's a little short. We got lots of short cords that we're dealing with today. We got to get some new longer ones.
Got to do something about that. But this is an actual live view showing an image of the sun as it appears right now at 12:34 p.m. Central Daylight Time on July 27th, 2023. So. If you're joining us after the fact, this is what the sun looked like while we were actually recording this show. But we are showing the sun live.
Yeah. So one thing I wanted to talk about a little bit is we are seeing, this view of the sun is pretty active, right? There's lots going on today. All these sunspots, all these, I guess not a ton of huge prominences around the edges, but we've got those filaments worked in there as well, right? Lots of stuff, activity. And so I wanted to talk about this kind of interesting ebb and flow that the sun goes through with these solar maximums and solar minimums. That might be a term that some of our viewers are familiar with. Right now, we're moving towards a solar maximum in spring 2025. So can you tell me a little bit about like what that means, what's going on in the sun to create this maximum and minimum?
Absolutely. So the sun goes through cycles of magnetic activity where we've got lots of activity, kind of like we do right now. So there's lots of activity, lots of prominences and sunspots and filaments and solar flares and coronal mass ejections. And you get this period of time of a couple, 2-3 years where you've got a high level of that activity. Then we kind of tail off into an ebb of activity, a lull in activity. And then we go back up to a high of activity. So how long is that time period? On average, it's about 11 years long for that high activity to low activity to high. It's really more like 9 to 14 years. It's not like clockwork 11 years. It's not like a planet orbit or something. So we are heading toward the high level of activity, and we'll reach that in probably the end of 2024. And then it will start to tail off. And then maybe 4 or 5-ish years after that, we'll be at the lull of activity. And I know this question, if you're not asking it in the chat right now, you're thinking it. Oh, is this why we're hot here on the Earth? No. No, it is not. This is not the cause of climate change on the Earth. If it was, we would see the temperatures on the Earth match this cycle of activity, and they do not.
No,
so,
we're looking at a graph more like this
yes,
than a nice up and down.
The temperatures are going up. They're not doing this. So, or not doing an up, down kind of cycle.
Now, this can have influences on some things on Earth, right? Like things like aurora being visible if the sun is more active, right? And it happens to send some of these CMEs like more towards the Earth and things like that, right? So there are some effects that can happen.
Yes.
But yeah, that is a good one to point out.
Exactly. One thing I wanted to do, because I figured I wanted to at least try to show you our setup, and so I'm going to do it the extraordinarily low-tech way, and that is I took a picture of it, and I'm going to try to put it in front of the camera.
Well, hey, a cell phone's pretty high-tech, so yeah, there you can see that actually doesn't look too bad. Here, why don't I switch just to this? So that is our telescope that we are using today.
That blue thing is the camera.
Yep.
So there you go.
And the big gold thing is the telescope.
Exactly.
So let me get us that sun view back. So one thing I did want to point out is, it's this idea of solar maximum and minimum is, we can see it with the features here that we see, right? And if we were looking at solar minimum, like especially sunspots are really affected by it. I think the last solar minimum, there was a really long period where there had been none visible,
which is normal. That happens.
Yeah, exactly.
You could have the better part of a year go by and see literally 0 sunspots.
Whereas like right now, if I were to go outside and I didn't see any sunspots, I would think that I had done something wrong with my telescopes.
Yeah, actually the spaceweather.com website keeps track of the number of spotless days. The current stretch is 0 days. So 2023 total, we have had not one day in 2023 that had 0 sunspots. In 2022, we had 1 day out of the entire calendar year that had no sunspots. In 2019, which was the last lull of activity, we had 281 days, 77% of the calendar days of that year had 0 sunspots. And so you can go right on spaceweather.com. It's the left-hand side of the page. I'm just reading right off here. And you can see this cycle of activity right in the number of days when we don't see sunspots.
And I have some really interesting graphics that like really showcase like why this is happening. So I have a couple of pictures that are going to showcase magnetic activity in 2 different time periods. So this one's in January 2011. And you can see, there's the magnetic fields are not going anywhere during these solar minimums, right? But they're a little bit more organized. You can see that we have like the 2 different colors, purple up top and green on the bottom, that are representing like the main magnetic poles, and lots of lines all throughout the main circle of the sun showcasing where that magnetic activity is. But it's pretty stable, especially when you compare it to this picture where they are all over the place. And I think what's particularly interesting here is look at where the purple and green lines are now. we've got a ton of purple concentrated on the top still, but also a lot down here. And then some of these green ones coming out of the sides. And that's because they're actually like actively switching. And that is what is creating these minimums and maximums, is these poles swapping, having this magnetic activity, changing a lot, and getting basically more erratic. If you look inside these areas of greater activity on this image, you can see like these black dots underneath that are showcasing like the actual exact features on the sun that are resulting in this. You can see we don't really have very many back in 2011. 2014, closer to the maximum, there's so much going on. And I think that really showcases well why we see those minimums and maximums. So you can imagine, this is what we got going on in the sun right now. It is, those magnetic fields are going haywire.
Yep. Why don't we switch back to the live view, and we will say a special welcome to anybody who might have been following the WGN TV Channel 9 in Chicago Twitter feed, because they just tweeted out that we're watching the sun right now live. So if you clicked on that link and you're joining us, hi.
Thanks for joining.
Thank you, WGN, for doing that. We appreciate it. We love those guys over there. They are wonderful. So hello to all our WGN followers. And it's really great if you're just joining us. This is a live, actually live, not a picture taken 20 minutes ago.
No stickers. That's what everybody always
stickers.
says to us. No stickers,
And
I promise.
I will prove that it's live. I will walk over to the telescope. I will adjust the position slightly so you can see that. And you'll hear my chair scraping across the table or across the floor. And I will move the image slightly.
All right, there's your proof. So that's a live picture right there.
Live picture.
So we're taking a look at the solar activity today. Now, one thing I wanted to say is, it's always fun to look at the sun, but there's a little bit of a particular reason that we're taking a look at the sun today, right? And so there are a couple of very exciting solar events coming up in the next year that we're really getting ready for here today. We love to look at the sun, but we particularly love to look at eclipses.
Exactly. So we've got 2 solar eclipses coming up in 2023 and 2024. Saturday, October 14th, 2023. From here in Chicago, you will see approximately 43% of the sun covered by the disk of the moon. So we call that a partial solar eclipse. It's not the level that it was in 2017, but it's still darn impressive amount of the sun to be covered by the moon. That does not happen every day. And then Monday, April 8th, 2024. That is a total solar eclipse elsewhere in the United States, but it will be a partial here in Chicago, where 94% of the sun will be covered by the moon. And our friends down in Southern Illinois, hello to our friends at Southern Illinois University, Carbondale. They're going to see totality again, which is great if the weather's clear. We hope it's clear. It is April after all, so who knows? But yeah, we've got those 2 solar eclipses coming up. So,
right, and we've been focusing kind of on how it'll look in Chicago so far. These are things that you can see no matter where you're joining us from, right? We've got folks from South Carolina. Sorry, not no matter where you're joining us from. Anywhere in the United States, especially the lower 48, we'll get really good views of these eclipses, particularly the total one coming up. You will see some kind of a partial solar eclipse if you are in the United States. So it's a really exciting time for astronomy here. Even if, like in Chicago, the annular one in October is not going to be as much coverage for you. It's just a little prep solar eclipse for the total in 2024, which very rarely do you get to say that there's one solar eclipse getting you ready for the next one.
Right, yeah, that's
we've been so spoiled over the last decade here, where we had that 2017 total solar eclipse as well. And then, a couple more solar eclipses that'll be visible here in the continental U.S. So we are feeling very lucky right now, and it will be quite a long time before we see another one of these.
So that ultimately explains why we're doing this show today. We wanted to practice our equipment setup for October 14th, 2023, because we want to do a live show for you for the eclipse as well. So if it's clear, I mean, we're going to do the show if it's clear or not. If it's clear, we will set up this same telescope that you're looking at live right here and on your screen, and we will show you the eclipse, and we'll see what it looks like that day.
And we really are trying hard to get the word out, make sure everybody knows about the eclipses. This is something that what I love about solar eclipses and lunar eclipses as well, all kinds of eclipses, is that they are an astronomy event that is so easy to view at home, one that really doesn't require very much specialized equipment. And it's one that, so many people are going to be able to take a look at. And so that's just what's so exciting about the eclipses, and why I love to make sure that everybody knows that they're coming up.
Exactly.
Especially one on a Saturday.
Exactly.
How lucky.
It's great to have it on a Saturday.
Yeah.
So we mentioned that eclipses are easy. You need one tiny little piece of equipment, and if you don't have that piece of equipment, there are other ways to see an image of the sun.
Yes, that's a really good one. So we always love to leave you with some ways that you can observe the things that we're looking at today. So today we're going to focus on some solar observing tips.
If you have solar glasses, you can get proper solar viewing glasses. If you have them left over from 2017 and you've kept them safe, dry, free of punctures, folds, rips, tears, anything, you should be able to reuse them. Hold them up to a bright light and make sure that there's nothing weird going on with any light getting through them. You may see a little bit of light getting through, but it's supposed to, because you want to let a little tiny bit of light through. But if you're in doubt, toss them and get new ones. We're showing you the picture of the glasses we had in 2017, and yours might look just like this or very similar.
I think lots of folks are familiar with these from the last eclipse. It was a really big event across the United States.
And if you need glasses, please go to the American Astronomical Society's eclipse website, eclipse.aas.org, and I think Jen is going to put that link in the chat. Eclipse.aas.org, and that will be in their eye safety section of that website is a list of reputable solar viewing manufacturers and reputable vendors to purchase from. Please refer to that list. The counterfeiting of glasses has already begun. And so we want to make sure everybody's safe, especially looking at the sun. You don't want to take any chances whatsoever. And so the proper way to use these glasses is you put them over your face, then you look up at the sun, then you look down, then you take them off your face.
That's a really good tip. Yeah.
So don't look up at the sun and then put them on. Don't do that. So on your face, look up, enjoy, look down, and then take them off. Okay? And some of these will be glasses, some will be solar viewer cards that you put in front of your face. The material,
our new ones are more rectangular.
The material is the same.
Yeah.
And so it's just, is it a form factor of glasses or a card that you hold in front of your face? So there you go.
Before we move on to some other observing tips that we have, somebody was asking what telescope we were using again.
Yep.
The view through this telescope right here is the Coronado. Jen, I'll type this out for you so you can post it in the chat too if you'd like. It's the Coronado Solar Max 90 millimeter.
Solar Max 2.
So yes, the Coronado Solar Max 90 millimeter. It's a really fantastic hydrogen alpha telescope. As you can see, it really gives beautiful views of the sun. Now, one thing I wanted to say about the solar viewers is, they're definitely primarily used for the eclipses, right? And that is definitely when most people have used them. But actually, it is something that you can use on any old day.
Yeah.
And recently we have had. I was out at an event handing out some solar viewers, and there was a sunspot big enough that I could see it just with the viewers. So during this solar maximum, where there's all of this really high activity, you actually could potentially see some of these sunspot features, even just with these glasses, which is pretty awesome. And that's some good practice leading up to the eclipse.
If the sunspot is at least is big enough, if it's at least I don't know. It'll look about that big on the sun. I don't even know how big that is.
I was going to say, that's kind of hard to describe.
It looks about that big.
Something
it's hard to describe.
What's something comparable on here that you could highlight?
Maybe about the size of this
about
area
that
right
one, I think
here.
you could probably make out. It'll be easier to make them out if you look them up on like some of the space weather websites, so that you know where to look for them and try and focus in on those spots.
Yep.
That can really help.
Exactly.
In looking for it. So.
If you don't have solar viewers or solar glasses, all is not lost. Make yourself a pinhole projector.
That's a good one.
All you need to do is take a little index card, something sturdy. It could be a piece of aluminum foil that you put a piece of Scotch tape on. Take a push pin or a needle or whatever and poke a little hole in the card, in the aluminum foil. You just need a nice, crisp little hole. And I'm talking pinhole. We're not talking big. We're talking tiny. And then have another card behind it as your screen. It could be a piece of paper, just something light colored. And you can line up the image of the sun through the pinhole and the card. You want to project an image onto that card. So you want to make a nice straight line between the sun, the pinhole, and the card. You're not looking through the pinhole. Do not focus a pinhole image of the sun on your eye. Don't do that. But you're projecting an image that you can then see on the card. And it'll be small, but you'll be able to see the eclipse. So
right, that one's particularly helpful for the eclipse because the shape of the projection will change as the moon's passing in front. So on a regular day, you will be like, oh yeah, of course, a circle of light comes through when going through a circle.
Yep.
But when it starts to change shape, that's when you see, oh, now I'm understanding this projection idea that's going on here.
But that's a good point. Go out on another sunny day and try it.
Right.
You can see a little tiny image of the sun. And depending on how far your card is, your screen from your pinhole, your image will get a little bigger, it'll get a little dimmer, but it will get a little bigger. So just find that nice size that you like. Remember that. And go out on the eclipse day and you can see an image of the eclipse on that little card. If you happen to have the solar viewers or solar glasses, you can look at the sun directly that way. Do not use anything ever that was not designed to look at the sun. So I don't want to hear anyone out there looking through exposed film or CDs or anything. If it was not built to look at the sun, don't use it.
We actually have a very related question to that.
Yes.
Can you use welder's glass 14 grade instead of regular Bader solar filter?
You can. You can use number 12, number 13, or number 14 welder's glass. The number 12 welder's glass, the sun it'll look a little bright, but it is technically safe. The number 13 is an uncommon number. It'll be hard to find just in general. The number 14 welder's glass, again, it will be a little dim, but safe. The problem is finding it, and you will have to go to a welder's supply store to get it. Do not go to a third-party vendor and get welder's glass. They counterfeit that also.
Oh my goodness.
So you want to go directly to a welder's supply store. Call them ahead of time and see if they have it. They don't always, they might not have it in stock because other people have thought of this same idea.
Right.
But you're going to spend an awful lot more than you will for a pair of solar glasses. A pair of solar glasses will cost you $2, $5, $7, whatever. Welder's glass, that's going to be a little pricier. So, but that should be your last resort, I think.
But I do like that question and that comparison because actually that is often how I describe the filters that we use to go on these telescopes. You can see these white light filters that we have here. The welder's glass is actually a pretty similar material to what we are often using on those filters. So that's a great question. That is another way that you can see it. And if you are able to get some kind of a solar filter, right, they have links for that on that AAS website as well. Not just for solar glasses, but also for solar filters. You can get ones that fit onto your camera if you want to do photography during the eclipse. It's very important that you are protecting even your cameras as well. Because you can kind of fry the sensors inside if you are taking too many pictures of directly at the sun like that. So you can get those kinds of filters, which will give you very similar images to what you see here. And actually, if you have few enough lenses on your camera, you can even potentially use your solar viewers to cover up those lenses. Some of them have too big of lenses, they're camera lenses these days. But you can get the idea.
Yeah, exactly. And so just make sure that whatever the solar viewer material is, it completely covers all your lenses, or there's cardboard around it covering the lenses. Do not let stray light in, and because you don't want to ruin your camera. So,
Right.
But yeah, many of these cameras now have 3 lenses, so cover them completely with your solar viewer. You may want to get 2 solar glasses or solar viewers, one for your camera, and you leave it on. Don't take it off, and then the other one is for you. So if you're buying one, you might as well buy 2, right? And so the other helpful tip is to take your camera, your phone, if you're doing it on your phone, cover it up, make sure it's all nice and safe, and with the solar viewer material, put it on a little camera tripod if you have it, stack it up, or put it up against a stack of books, something to keep it steady, and take a video. Don't take a still image, because have you ever noticed you're out and about, the lighting is weird.
Right, especially during the daytime, it can be hard to see your screen and really get the settings exact.
And you take a picture, and your camera does that focus in, focus out thing, and it just does that. Well, it may keep doing that, so you don't want to...
It's not particularly made for solar imaging most of the time. Yeah, different than what it's used to.
So take a video. You may have to tap on the image of the sun and then reduce the brightness a little bit. But take a video and do that. Hopefully, at least one of the frames of the video will be good.
Yeah.
You have a better chance than trying to take individual images, because your camera may not be able to focus on that. But if all you want to get is the sun and the moon, you're good.
Yep.
If you get sunspots, bonus. But don't be surprised if you don't see
It'll be pretty tough.
That'd be tough.
Whenever I take pictures like of something like the sun or the moon with my phone, I'm always surprised at how small they really are in the sky relative to how vast the sky is, how big it is above us.
Speaking of which, I know you're all out there. I know there's people watching. I want you to do this, because I'm going to do it. So I want you to do it. I want you to do it too.
Okay.
Do me a favor. Take your thumb. Stick your thumb out. Hold it out at arm's length. All right. The size of the full moon in the sky is 1/4 the diameter of your thumb stuck out at arm's length. Well, the size of the sun in the sky is 1/4. Don't look at the sun and do this, but look at the moon and do this. But the size of the full moon, so it's full moon, so we're recording this July 27th, it's next week. So the size of the full moon in the sky, your thumb held out at arm's length, it's 1/4 the diameter of your outstretched thumb. And that is 1/2 of 1 degree. If the entire whole sky above you is 180 degrees, the sun and moon are 1/2 degree.
Yeah.
They're tiny.
So they're obviously much bigger than everything else in the sky, but still relatively small. So it definitely does take some.
You can all put your arms down. Okay,
thanks for playing along with us. Well, I think we covered a lot of what I wanted to cover today. If anybody has any last minute questions in the chat, one thing I wanted to leave you with is we've talked about ways that you can see the sun, but all of them are a little different than the view that we're getting today. Now, getting an H-alpha telescope, if this is your first time looking through one or using one, this is a pretty specialized one that most people are not going to have at home and things like that. So I wanted to give you at least one way that you could see some H-alpha views of the sun at home that are actually pretty much live views just like you're seeing today. And that's this really cool website that is run by NASA and ESA that is helioviewer.org. And I was having so much fun playing around with this website, getting ready for this show. You get access to so much NASA solar observing data. There's constantly tons of telescopes pointed at the sun. And so this is all live views. You can go back through decades of observing data, look at all of these different kinds of telescopes. They have much more particular filters than we have that will reveal way more details. And you can even put together little movies of some of them. So I put together one that I thought was really cool. That was the coronal mass ejection in 2012 that you had told me about. That we were lucky missed the Earth because it was a really huge ejection. So just to give you an idea of what kind of stuff you can see on here, it'll come when the time says 2:30 in this video. You'll see it'll be pretty obvious. A huge eruption of solar material. So that little ball in the middle, that is the entire sun that we're looking at today. All of that is all of this extra stuff erupting off. It's just incredible.
And by the way, I'm looking over here because this is the screen.
Yeah, this is where we have the
that's
monitor
why I'm not
for it.
looking at the. Yeah, that's cool.
So you can really find a lot of really cool data. Find like old events. You can even see some of the sensors getting fried after it like is finally reaching Earth.
Yeah, it did not fry the spacecraft, but you can see that white stuff. What appears to be white stuff is radiation. It's charged particles, protons, electrons that hit the sensor, and you can see it on the image right here. So pretty cool.
It's a really fun website to mess around with, and it is a great way to access a ton of really interesting solar data.
Yep. And Jen's putting the link to helioviewer.org in.
Yep.
But
we'll finish it off with our actual live solar viewing or solar observing data here, straight from the Don't Observatory at the Adler Planetarium. Thank you all so much for joining us today. Michelle, did you have any last words that you wanted to say to the chat here?
If you would like to join us here at the observatory, we don't look at the sun during the day here, but we do have it open at night. So Wednesday evenings, if you'd like to come to, if you're in Chicago, if you live here, Wednesday evenings when it's clear out, we have the observatory open after sunset. The time will change depending on the time of year, if it's cloudy out or what have you.
Right.
But if you want to follow us at Scopes with the Adler on Facebook, we have a Facebook group, so you can keep up with whether or not we plan to have the observatory open. We were open last night. We saw the moon. It was really great.
And they'll post all kinds of other observing opportunities that we have. Some of our outreach things that aren't just at the planetarium, some things at other places around Chicago.
Exactly.
So that is a great place to go if you're interested in looking through one of our telescopes yourself.
And we will have public events for the solar eclipses coming up. Please come and join us.
Yep, if you're here in Chicago, this is the place to be.
Saturday, October 14th, 2023, 10:37 a.m. Central Daylight Time to 1:22 p.m. Central Daylight Time are the times for Chicago. Other places in the country will see the eclipse at different times. So you want to, that's the time for Chicago. Our event runs from 10:30 in the morning to 1:30 in the afternoon. And then the Monday, April 8th, 2024 eclipse, that eclipse is in the afternoon. But we'll just concentrate on the October one for now. Come on and join us
Long
that
ways
Saturday.
until next April still.
Buy a ticket to the Adler. Come visit. Come see our brand new exhibit opening Saturday called the Stargazers Hub. We can't wait to show you that. So that's coming. We will have a temporary exhibit starting in September called Chasing Eclipses. And it's about people, it's about the act of actually going to eclipses. What have people built? What have people used? What have people done to be able to predict eclipses and then see them in person? So we can have you come and do that. It'll be a lot of fun.
All kinds of exciting reasons to visit. But if you're joining us from anywhere else, we would still love to stay in contact with you. Subscribe to our YouTube channel here to see future live streams. We'll be live streaming during the eclipse in October using this exact same setup as our plan. And so you will see us back here under this tent in just a few months. We are very excited for it. So subscribe to the YouTube channel to get that stuff. We also would love to hear about your observation reports. We're not just worried about our observing, so make sure to send us any solar observations that you do, whether it be with some solar viewers, a pinhole projector, a telescope of your own. We've got a couple of different links here for our social media channels. We like to use the hashtag #lookup because that's always what we're encouraging folks to do. So make sure that you're posting your celestial views, sharing them with us. We also will have Jen post a feedback survey in the chat that you can respond to. Even if you've responded in the past, even another one is super helpful. You can give ideas for future shows.
And we really do read it.
We really do. Yes, you can give recommendations for how we can improve our shows. We're always trying to make sure that we're doing things as best for all of you, and also that we're observing the things that you're interested in. So you can submit potential subjects for future shows, all kinds of cool stuff. So thank you for posting that in the chat for us, Jen.
Thank you. And everyone, if you want to have a little homework assignment, make a little pinhole projector, take a picture of it, send it to us. Send it to the Adler social media feeds, use the hashtag lookup. We would love to see that you have your equipment ready to go.
We really would.
To see the sun. Yeah, we would love to see that. Thank you, everyone, for joining us. We really appreciate it. And keep looking up.
Yes, keep looking up. Absolutely. Bye. Bye, everybody.
Bye.